Hello, in this tutorial we will fix texture stretching, which happens when we scale our object. There are several ways to do so, and we will look through all of them today. So first, let's go to Blender and open Node Editor. Let's select the material that we want to fix, and first we will look at the easiest way to fix stretching textures. Let's go to Input, and here we will need the node Texture Coordinate. And instead of the UV map, we need to use Output Object for this node. And let's plug it into vector input of color texture and normal map. Now from one side the texture is sitting correctly. And if we try changing measurements of the cabinet, the texture will not change. To fix the texture for other sides, we will need to change the flat parameter in the texture to box. This projection type fits perfectly for our case, because our cabinet is rectangular. Also, there are other ways to project the texture, which will work for other objects with different shapes. Alright, now let's try stretching the object. And we will see that the texture is perfectly still. It doesn't stretch. But there is one problem. The rotation of the texture has also changed. Now the wooden fibers are rotated in a way which is perpendicular to the longest side of the cabinet. To fix it, we need to rotate the object itself. We cannot fix it inside the material. So, to fix this, we need to rotate the object, the cabinet, itself in a way so the texture sits on it correctly. And then we will apply this rotation and rotate the cabinet back. First, let's rotate it by 90 degrees by Z-axis and apply rotation. Alright, the fibers rotated, and on this side they are aligned correctly. Also, we need to rotate them here. So for that, let's rotate the cupboards by 90 degrees on Y-axis and apply rotation again. Alright, good. Now all the fibers are aligned correctly. Now we just need to rotate the cupboards back minus 90 degrees by Z and Y axis. And our cabinet is back to normal. But now we don't need to apply the rotation, because if we do so, the texture will shift again. Here, let's undo it. Now the textures are aligned in the right way, and when we change cabinet size, they don't stretch. Now we need to do the same, but for all other objects. For example, for this shelf. Let's rotate it 90 degrees by Z-axis and apply rotation. And then rotate back by minus 90 degrees. Let's check, and yep, the texture here is fixed as well. So let's do it for other objects. The next will be doors. I will rotate them 90 degrees by Y-axis. Apply rotation and rotate back. And same for the second door. Now let's check, and yeah, the texture is not stretching. Next, let's check the drawers. And they actually already are aligned just like we want them to be. So we will leave them as is. Next, let's fix the sliding door. Let's also rotate it 90 degrees by Y-axis, apply rotation and rotate back. And of course, it also doesn't stretch. Alright, we fixed all the objects, now let's export and look at it in the application. Let's reload and change the cabinet size. And looks perfect to me, the texture does not stretch and looks good. also works well with all other objects, doors, drawers, etc. If we need to change the size of the texture, we can just use the nodes mapping, just like we would do with UV coordinates. So now we can correct the scale of the texture if we want it. But sadly, if we try to rotate it, the mapping will break right away, so we need to use this method with rotating manually. Alright, let's look at the next method. It is kind of similar to the method that we already know, but it gives us more freedom, and we can even rotate the textures. First, we need to create a special mask to project our texture from different sides. For that, we will need special node geometry from the input nodes. Let's place it here. And also let's add an output node here, so we can see the changes right away. Alright, now we have black, blue and red mask. Based on this, we will create our own masks to use for the projection from all sides. Also, I will add here a sphere and apply a material, a wooden material, which we will be working on. Material table mat. So we need the sphere, because it will be much more convenient to see the masks on its surface. Okay, next we need to separate this mask into 3 channels. For that we will need a node separate XYZ from converter nodes. And now we are looking at the X-axis projection. The sphere was divided in half, half is black, half is white. And of course the same with our cabinet. So now we have separation between left and right. The same will happen for Y-axis if we separate the Y channel. We will have the separation between fronts and back. And the same by Z-axis, from top to bottom. But we don't need the division along one axis. We want to divide between axes, so for example, left and right versus top and bottom. So now we need to take left parts and right parts and combine them together. For that we will need the nodes math from the converter nodes. Let's place it here between the separate XYZ nodes and output. And here let's change add to absolute. And now we have the black gradient coming from the sensor to both left and right, so both left and right are now white. And the same happened to the cabinet. We have separated left and right from other sides. Next, let's stretch this mask a little bit. For that we will also need the node math. And instead of absolute, let's select multiply. This will let us change our gradient, stretch it a little bit. If we increase the multiply parameter, the gradient will become smaller and smaller. This gradient will be a transition between texture projections. Now the black part is very thin. To increase it, we will also need the node math. Let's place it here and we will leave it at add. Now let's decrease add value. That will increase the black area. And we want black part and white parts to be about the same area. We want something like this. Okay, now let's select these 3 nodes and press Ctrl G to group them. And let's name this group Mask Control. Now that we have all the math in one group, we can copy it and use it for other axes. Let's add this mask for Z axis. Let's take Z output from the separate XYZ node, plug it into our mask, and then plug the result into the material output. And now we have the same mask on different axes. And even though we have 3 axes in total, we will actually only need 2 masks. So here we will also need another node. This will be a node mix color from the color nodes. Let's place it here. Now let's use our first mask as a factor here. Then let's choose red as first color and green as the second color. Now it is noticeable that the colors were separated. Left and right parts of the cabinet are now green, while top to bottom and near to far are red. So we have successfully separated the first channel or red channel from other axes. Now let's duplicate the mix color node and place it here. The output from the first mix nodes will go into input A, and our second mask will work as a mix factor. Also, let's set B input to blue, so we can clearly see color separation. All 3 axes are visibly separated from each other. So the top and bottom are separated from left and right, as well as from front and back parts of the cabinet. Though it seems that we have a bit too much blue color. So let's select our group mask control and press tab to open it. Now let's edit it. We need the ratio between red, green and blue to be about the same. Let's increase add value here. And it seems to fix the issue. The ratio is about equal. Let's press tab again. And now what we need to do is to change the colors with our texture. Let's move it a little bit to give the texture nodes more space. And we will start by applying color texture. Let's delete UV map node, because we don't need it anymore. Then let's add texture coordinate node from the input nodes. And here let's select object. But unlike the first method, we will not be changing flat to box. Instead, we will just plug our texture into one of the color inputs. Let's use red color. And now instead of the red color, our texture is being projected along one axis. And here between the coordinate node and image node, we can add and use mapping node. And this time the rotation will actually work correctly. So let's rotate our texture until we get the desired outcome. For example, let's rotate it by 90 degrees on y-axis, but nothing happened. Let's try the same on x-axis, and here we go. The texture is now rotated in the correct way. We can also use other rotation options to correct other axes. Now we need to add the texture for 2 other axes. Let's just copy this whole setup, connect it with object output, and let's plug it in the place of green color. And now we have left to right projection. Now we need to set up the rotation for this axis. We want the fibers to look down. So we rotated it 90 degrees by y-axis, and now we have exactly what we want. Alright, and next comes blue color and z-axis. Let's copy this setup again and plug it instead of the blue color. Let's check the texture, and it is rotated incorrectly. Let's rotate it the right way. Now here we just need to set all rotations to 0, and we will get the right rotation. And now the moment of truth. Let's change the measurements of the cabinet and check if the texture stretches. And here we go. The texture stays as is while the cabinet is changing. This method also lets us change the scale for certain axes if it is needed. For example, let's try scaling the texture by the axis. As for the other textures, the scale stays the same. So, with this method, we have much more control over the texture mapping. Also, let's not forget the normal map. We need to do the same for normal map, just like we did for our color texture. Let's copy it 3 times and plug in corresponding mapping node outputs. Let's also copy these 2 mix color nodes, replug the corresponding factors, and here as well, instead of red, green and blue, let's assign normal map. So each normal map will correspond with its color texture. And now let's plug this whole setup into the normal map node. Let's also plug in the color texture setup into the corresponding mix color. Also, let's delete this temporary output node, so we will have only one active output. Alright, and now our material setup is fully finished. But we might notice some problems. For example, the texture on this shelf is not rotated correctly. To fix it, we need to create a unique material for this shelf, copying already existing one. And inside of this new unique material, we will rotate the texture just the way we want. Let's create a copy, name the new copy with postfix 2, and here we need to edit the rotation of the texture by z-axis. Let's rotate it so the fibers of the wood will lie horizontally. Let's rotate by 90 degrees on the axis, and here we go, the rotation is fixed. Next, let's look at the doors. Here we also need some rotation, so let's create another material copy with postfix 3. Let's rotate the first texture, which is projected along y-axis. Y-axis doesn't work. If we drop everything to 0, doesn't work as well. Let's undo it and try rotating by z-axis. And here we go, the rotation is correct. Now we need to assign this material to the second door. So, if we change measurements of the doors, the texture will not stretch. Let's check the drawers, and they have the correct mapping. Next, the sliding door. It also needs some fixing. Let's actually try applying the third material, and it works perfectly. Next will be the legs. They also have incorrect mapping of the texture. Let's try using the third material for them as well. And here we go, the fibers are now rotated vertically. Exactly what we need. Let's export everything to Verge 3D and check it in the application. Let's reload, try changing the measurements, and everything works correctly. Let's try changing the color, and the color is changing only on one material. To fix it, we need to go to the puzzles. Let's go under the color tab, and here we need the animation to play not only for the table matte material, but also for table matte 2 and table matte 3. Also, we need to do the same for the switcher. Let's add animation to table matte 2 and table matte 3. Let's save, reload, and try changing colors. And here we go. Everything works perfectly. The next method will be adding individual masks on our object. We will use the same principle of projecting the textures, but now instead of automated masks from coordinates, we will be using vertex colors. So let's talk about vertex colors first. Vertices don't only have the information about their location, they may also have color information. So they have red, green and blue info channels. And we can use this information as masks. So let's do just that. Let's go to Mesh Properties, press a plus here under the color attributes. Then let's call it Mask. Then here we need Vertex, here Color, and for the default color, let's change black to red. Now very important part, we cannot just pick a color from the color palette. We need to set the color directly, numerically. For the masks to work the correct way, we need the exact numeric values. Right now we need red to be 1, green 0 and blue channel also 0. Let's press OK, and now we have our vertex color mask. Now let's press Alt tab and go to the vertex color editor. To see our mask, we need to go to solid shading. And here we can see that the whole surface of our cabinet is red, default color that we have just chosen. Now we need to add other colors to other areas. Red color will be for left and right parts of the cabinet. Green color will be for the fronts and back. And blue for the top and bottom. So in this method we will be applying the colors for masks directly by hand, while in previous methods we have used coordinates to do it automatically. Alright, first let's paint the color for fronts and back sides. First let's go into the edit mode. Here let's select face editing and press C, so we will get circle selection. Now let's select all the faces on the fronts and back. It is very important to be very careful while selecting the faces. If we select any faces on a side that we don't want to, our mask will not work correctly. Alright, here we have selected all the front faces, and now we need to select back faces. Now let's go into Vertex Paint Editor. Next we need to press this button, which is called Paint Mask, and it will separate our selected faces from other geometry, and we will be able to paint only on selected faces. Next let's go to the Tool Properties, and here let's select Green color. We need to do it just the same way as before. Let's bring red channel and blue channel to 0 and green to 1. Alright, now let's press Shift K, and it will paint all selected vertices at once. They will become green. Okay, next we need to do the same, but for the fronts and bottom areas. Let's go into Edit mode, and here select all the needed faces. Now back to Vertex Paint, and here let's select blue color. Let's press Shift K, and now we have blue mask as well. And now our mask is ready. Let's close Vertex Paint mode. And now we need to implement these masks into the material. Let's go to Input Nodes and grab here Color Attribute node. Inside these nodes we need to select our mask, which we just created. We will implement this mask the same way that we used previously with coordinate masks. We will need the node Separates Color from the Converter nodes. Let's grab Color Output from Color Attribute node and plug it into Color Input of Separates Color node. And here the output channels will go into our Mix nodes. Red channel will go into the first color mix, and green will go into the second. And now the textures are on the cabinets again, though it seems that I used the wrong channel. Let's grab blue channel instead of green channel, And here we go, now everything works correctly. And of course we need to do the same for normal maps. Red channel goes into the first mix, and blue channel goes into the second mix. Now the normal maps also have correct coordinates. And of course, if we try changing the measurements of the cabinets, the texture will stay in place and will not stretch. This method works the best when you have complex geometry and the first two methods, automatic methods, don't work very well with this geometry. Let's export it to Verge 3D, reload the application and check how it works here. Let's try changing the measurements, and everything seems to work perfectly. The only downside of this method is that it requires a lot of time, because we manually paint all the faces. But in some situations, only this method will actually work. Now let's look at another possible issue. Sometimes it is not possible to use the texture with automated coordinates, like we did in previous methods. So we will have to edit UV mapping manually. Let's delete our mapping setup and use UV coordinates instead, just like we had in the beginning. First, let's add main mapping node. So we can easily edit the scale for all the textures. Then we need to add some more mapping nodes for each of these textures. We need this to individually correct the scale, so when we change the measurements of the cabinet, the scale of the textures will be changed as well, thus negating the stretch. Also, we will need spatial nodes, which are called combine X, Y, Z. Let's plug them into the scale input of each mapping node. Also in this node we need to set everything to 1 by default, so the scale will be set to 1. Now we can plug value nodes into this node, and then, thanks to value nodes, we can control the scale using puzzles. So let's add 3 value nodes, which will correspond to measurement changes: height, width and depth. And let's name these values accordingly. Let's press N to open nodes properties, and here let's type, let's say W size or width size. The next node will be depth size, and the third H size or height size. And now we need to find which parameters corresponds to which measurement. For that, let's just try scaling them. Let's start with the first texture. So the first one is a texture which is aligned on the fronts and back sides. Let's try editing it, and when we edit it by x-axis, we can see that it stretches the texture along width, and y stretches it vertically along height. So let's plug the width value into the x and height value into y inputs. Now let's check second texture. Let's try x, and looks like x corresponds with height. And y corresponds to depth. So D size node will go into y input, and H size will go into x input. Let's also set our values to 1. Now let's check the third texture, which is projected from top to bottom. Seems that x corresponds with width, and Y with depth. So D size goes into Y and W size goes into X. And now by editing these values, we can edit the stretch of all textures. On width, depth, and height. So let's export, and we need to go under the size tab, and there we will be animating these values. Let's copy this setup. Instead of set door position and get door position, we will need set value puzzle. And get value as well. Now the material will be table mat, and the value will be W size, as we are now editing the width change. Now let's leave these values by default, we will not be editing them, we will only need to edit to min and to max. Minimum will be the default scale, so let's set it to 1. And maximum will be the maximum stretch that we will need to counter the maximum possible width change. I have already calculated the needed value. It will be 1.75. Alright, and now we need to add updated value puzzle. And now let's test it in the application. Let's change the width. And the texture is changing with the width change. However, the texture is visibly rotating or sliding along the geometry, and this behavior is connected to UV mapping itself. UV coordinates start from the left bottom, and then it rises up and to the right, diagonally. That means that the sensor of scaling is in the left bottom corner. And when UV islands are placed away from this corner, when we try to scale the UV, these islands start also moving away from the sensor, thus the sliding motion. To fix it, we just need to place all our UV islands into the left bottom corner, so the centers of the islands will match the center of coordinates. We can do it approximately, but of course it is better to do it ideally. The better is the match, the less sliding we will get. I will place these islands just like this. Let's not forget the small ones. And now even if the slide will be present, it will be almost unnoticeable. Let's export everything and try in the application. Let's change the width. And now it works almost perfectly. We do have a tiny little slide that is almost unnoticeable, and it all depends on the precision with which I have placed the UV islands. And now we need to do the same for other measurements. Let's do height first. Let's copy this puzzle. Instead of set position, we need set value and get value. And of course we will need H size for height measurement. Now here in the map range, in the field to max, I will need 1.65. Alright, let's try changing the height of the cabinet. And here we go, the texture stretches perfectly. Now let's do the same for depth changes. Let's copy this setup. Change get and set position to get and set value, and it will be for the size value. And here the maximum will be 1.45. Alright, let's test it in the application, and everything works perfectly. There are still some slides though, and if we want to increase the precision, we will need to fix it with UV mapping. Alright, that's all. In this tutorial, I tried to look through all the possible fixes of texture stretching. And of course we can always combine these methods. We can use UV changes with some automated coordinates, or we can also add some masks with Vertex paint. So depending on the project, we can use one of these techniques or combine them. Alright, that's all. See you in the next tutorial.